Hi, everyone. Let's do problem 19 from the EC3 or lesson 5.3 homework. So we've got our function f of x is equal to x divided by x squared plus 1. And we need to find intervals of increase and decrease and local maxima and minima and concavity. So intervals of increase and decrease will be from f prime, right? We're going to need to know f prime. Also, local max and min are going to be from f prime. And concavity, we're going to have to look at f double prime. So we'll start by finding f prime. So use the quotient rule to do low d high. Remember that d high is just 1 minus high d low over low squared. That's f prime. And we're gonna just clean up the top before we proceed. Very important to clean up the f prime before you set it to 0 and solve. So we get 1 minus x squared over x squared plus 1, the quantity squared. Okay, now we need to think about critical points. Critical points are places where f prime is equal to 0 or f prime is a DNE. DNE in this case, there will be none, because if you look at this denominator right here, x squared plus 1, the quantity squared, that's always going to be a positive number, and it's never going to be 0. You can also take it and set it equal to 0 and solve. If you don't see it just by looking at it, you can set it equal to 0 and think about that. The square root of 0 is 0, and then we're getting x squared equals -1, so x is equal to the square root of -1, which is I, right? So it would be imaginary, and those are not going to be numbers on the x-axis. So we do not need to worry about f prime equals DNE places. We need to just worry about f prime equals 0. For a rational function like this f prime, when we set the equation to 0, it's like setting just the numerator to 0. You can cross multiply to see that. And we get 1 minus x squared equals 0, so x squared equals 1. X is equal to plus or minus the square root of 1, which is plus or minus 1. Okay, so I now have my f prime equals 0 and f prime equals DNE. I have my critical points. So I go off to a sign chart, and on the sign chart, we need both the -1 and the +1, which are the only critical points. Then I'm going to do test points to figure out the sign, the SIGN of f prime. So let's do that. I would choose 0 for sure and go f prime of 0 is 1 minus 0 over 0 plus 1 squared, which is 1. And we could then do f prime of any number to the right of 1, really, but I'll pick 2. As my other test point, and so I do 1 minus 2 squared. I'm using the f prime equation. Be careful not to use the f equation. And we get 4 plus 1 squared on the bottom. So I think we're getting something like -3 over 25. And then if we do the same thing with -2, we're going to actually get the same thing. We're going to get, again, -3 over 25. Okay, so I have concluded that the signs are like this. We are negative here, negative to the left of -1 for the f prime. We are positive in between -1 and 1, and we're negative to the right of 1. So this is my f prime. So that means my f is decreasing, increasing, and decreasing. I have now, as far as f goes, I have a local minimum at -1. So be clear that the local minimum is at x is equal to -1, and the local minimum value of f, that means the y value there, would be f of -1, which you go back to the f function, which is x over x squared plus 1, and put in -1, and you would get out -1/2, right? So always remembering that if the question says what is the local minimum value of f, then you have to give back the y value. But we are now aware that there is a local minimum at an x value of -1. Then we have a local max here, right, at x is equal to +1. And you can say it like this: f of +1 is the local max, and the y value is going to be, again, x divided by x squared plus 1, so 1 divided by 1 plus 1, or 1/2, okay? So again, the rationale is that, f prime is negative to the left of -1, so the function f is going down, and then it starts to come up right at -1. So this is our local minimum, and then for x equals 1, we're increasing until we get to 1, and then we're decreasing, right? So that is going to be a local maximum. Okay, so concavity when it comes to rational functions can be a little challenging because we have to do a second derivative. And in this function, f prime is already this rational function. So we have to differentiate it again, and that can be a little tricky, but we'll get through it. That's actually why I'm making this video, to show you that. So we've got f prime here. Let me rewrite that down here so I have some room. F prime is equal to 1 minus x squared over x squared plus 1, the quantity squared. Okay, so now take a deep breath and do the quotient rule. F double prime is low d high minus high d low. Now, thinking about this d low, let me just color code this here. This guy, this low here, let's go off to the side and discuss the d low. X squared plus 1 squared is low. So d low will be a chain rule. Out prime of in times the in prime, right? Let me write this out. Outside function is x squared. Inside function is x squared plus 1. In prime is 2x. Out prime is also actually 2x, right? So out prime of in means we're putting this guy in here. So out prime of in is right here, and here's my in prime, okay? So that's low d high minus high d low. So I have to bring this whole d low. I'm going to multiply the 2 and the 2x to make 4x, and then write that over here. Okay, and it's all over low squared, which becomes x squared plus 1 to the power 4. Okay, so we are going to improve our algebra skills right now because we have to clean up that f double prime numerator, right? So let's expand this right here. Let's expand this. Remember that that's not x to the 4th plus 1. It's x to the 4th plus 2x squared plus 1 times -2x. And if you forgot y, let me remind you that x squared plus 1, I'm going to go off to the side to remind you that when we're saying x squared plus 1 to the power 2, that means x squared plus 1 times x squared plus 1, and you get x to the 4th plus x squared plus another x squared plus 1, which then becomes x to the 4th plus 2x squared plus 1, right? This is called a cross term, and we want to make sure that when you square a binomial, you do not forget the cross term. So there we have that, and then over here, we're going to have to just multiply all this out. So I would just do minus 1 minus x squared, and then I can say 4x cubed plus 4x. And then in my next step, I'll distribute all of that, or FOIL all of that. So I'm going to get -2x to the 5th minus 4x cubed, right? What I'm doing here is all of this, minus 2x. And then I'm going to put parentheses here just because I first have to do this multiply, all this multiply, before I distribute the negative sign. So I get 4x cubed plus 4x minus 4x to the 5th minus 4x cubed. Looks like our 4x cubes are going to cancel. And And now I can now open out those parentheses, distribute that negative sign, and maybe I'll get lucky and something else will cancel. Who knows? We will see. No, nothing canceled, but I can combine things. I can say 2x to the fifth, right? Combining this guy and this guy. And I can combine this. Well, no, I can't do that. I can combine this guy and this guy. So I can go 2x to the fifth minus 4x cubed minus 6x all over x squared plus 1 to the fourth. So a little bit of algebra, but nothing actually that dramatic. It's just about keeping things straight, remembering things like this, remembering how to distribute this negative sign here properly after you do the multiply, things like that, things that we do need to practice. Let's take f double prime and now make a sign chart for it. So I'm going to think about f double prime equals d and e, potential places, and f double prime equals 0, right? So f double prime equals d and e, actually there is nowhere similar to the logic behind f prime equals d and e, right? You look at this denominator and you realize that there's no real solutions to that being 0. So f double prime equals d and e is nowhere. The top, we set that to 0 for the f double prime equals 0, and we think about how to solve that. And we can pull out an x, so we'll do that. And then, actually, you can pull out a 2x, so we'll do that. And then we'll think about the rest. So I have 2x times x to the fourth minus 2x squared minus 3. And oh my, I see a quadratic type equation, which we have covered in pre-calc, right, where it's x to the 4 and x squared, but I can solve it just like I would solve a quadratic equation by factoring. I need two numbers that multiply to -3 and add to -2, so those will be -3 and +1. And so this is going to boil down to 2x times x squared minus 3 and x squared plus 1, right? X squared because I don't have x squared and a number. I have x to the fourth, x squared and a number. It's the quadratic type factoring. Okay, and so then I'm ready to find the roots. X equals 0. That's by setting 2x equal to 0. X squared minus 3 equals 0. X squared equals 3. X equals plus or minus root 3. X squared plus 1 equals 0. X equals plus or minus I, right, again, because x squared would be -1. And so don't have to worry about that. So my concavity is going to be determined by looking now at a sign chart for f double prime. I'll set these two numbers onto my number line, 0, or three numbers really, because I have a rad 3 and a minus rad 3. You have to remember things like, rad 3, it has to be greater than rad 1 and less than rad 4, right? So that means it's a number between 1 and 2. So you then can choose convenient numbers in the various intervals. Let me color these intervals. I'll make them 4 different colors so we can talk about each one, right? And so you could do f double prime of, say, 1 in the green interval, f double prime of 2 in the yellow interval, green, yellow, f double prime of -1 in the blue, and let's say f double prime of -2 in the red. Okay, so we just have to figure these out and then we're done. Okay, so I have to remember my f double prime equation. It's way up here somewhere. So it's 2x to the fifth minus 4x cubed minus 6x over x squared plus 1 to the fourth. I'm just going to rewrite it down here so I don't have to keep scrolling up to see it. Oh, no, I forgot what it was. So f double prime is equal to 2x to the fifth minus 4x cubed minus 6x divided by x to the x squared plus 1 to the fourth. Okay, so here I've got my thing. Okay, so let's see. If I put in 1, I'm doing all this to make sure you realize you have to do this without a calculator, right? I mean, Yeah, it's not that much easier with a calculator, but okay, 2 minus 4 minus 6 over 2 to the fourth, and that's 2 minus 10, negative 8 over 16, and negative a half. Then f of 2, we would do 2 to the fifth is 32. So 64 minus 32 minus 12. 32 minus 12 is 20, and then we're over 2 squared plus 1 is 5, 5 to the fourth, right? So you can just leave it like that. Remember, you just want to know the sign. You want to realize this is greater than 0. Let's do negative 1. So f double prime of negative 1 is going to be negative 2 plus 4 plus 6 over 2 to the fourth, right? So this is going to be 8 over 16. It's going to be positive 1/2. And then the last one, negative 2, that one will be negative 64 plus 32, negative 6 times negative 2 plus 12. And then in the denominator, things will not change from before. It'll still be 5 to the fourth. So let me see, negative 64 plus 32, always go left to right. That's negative 32 plus 12 is negative 20. Negative 20 divided by 5 to the fourth is less than 0. Okay, so we are just looking at whether things are less than 0 or more than 0. Okay, so I can say that in the green interval, I am less than 0, right? So negative. In the yellow interval, I'm greater than 0, so positive. In the blue interval, we are also positive, and in the red interval, we are negative. Right? So that gives us our concavity. We can now say that f is concave down from negative infinity to negative root 3, concave up from negative root 3 to 0, concave down from 0 to root 3, and concave up from root 3 to infinity. And that's our answer. You can write it out together. You can say something like f is concave down on negative infinity to root 3 union 0 to negative root 3 union 0 to root 3. And then f is concave up on negative root 3 to root 3 union root 3 to infinity. So that would be the answer to part C. It's the intervals of concavity. So I think we've done everything, intervals of increase and decrease, and intervals of concavity and local maxima and minima. So hopefully that was helpful. I'd like to end by just making a quick comment about what we call the second derivative test for local maxima and minima, right? If we go back up to the beginning of the problem, we found our local maxima and minima by using the first derivative test right here. This is called the first derivative test for local maxima and minima. So we found it by looking for a sign change on f prime, right? You can also use the second derivative test. It doesn't always work, but when it works, it can be useful. In this problem, honestly, the second derivative is complicated enough that I feel like it's not a big benefit, but I just want to show you that second derivative test says that if you find the critical points, right, so f prime was 0 at negative 1 and 1, so I have f prime of negative 1 equals 0 and f prime of 1 equals 0. These are the critical points of the function f. Now, if I find f double prime of negative 1 and f double prime of 1, and if those are non-zero numbers, and I think we found them down here, I just have to remember what they were, f double. Okay, so f double prime of negative 1 was a half, and f double prime of 1 was negative a half. So we remember that on a concave down curve, f double prime is going to be negative, and on a concave up curve, f double prime is going to be positive, right? So that holds for these places where you might be at a max and a min. So if you are already at an f prime equals 0 place and you find that f double prime, like here at -1, is positive, then this must be a local minimum. And if you are at a place where f prime is 0 and f double prime is negative, like in this case at +1, that must be a local max, right? Because you must be concave down then at that spot, and you must be at the top of a hill, local max. So keep that in mind. A second derivative test is always something to consider as well.